Okay, so we're going to look at this thing. We're going to read that. We've got 20 divided by into 5 divisions, right? So that looks like each division is 4. So I think our initial amplitude, I'll call this the amplitude. The initial amplitude is 56 centimeters. Okay, and then after one cycle, it looks to me to be about 40. So I'll call this 1. I'll call this guy 2. Okay, is 40. I'm having a hard time, calling it something because x naught usually means like the original x. Okay, but in this case, x naught means the amplitude, right? Okay, and then what we're going to use is we're going to use the Q is 2 pi times energy stored over dissipated in one cycle. Okay, how much is stored in the first cycle over how much is dissipated. And what we do is we use these little points right there. Okay, so the initial one is 56. After one cycle, we're at 40, right? And so to do this, we got to realize that the energy is proportional to the amplitude squared, right? Because it's 1/2 m omega amplitude squared, right? So since it's a ratio, we don't need the 1/2 and the m and the omega. We can just do this, right? So we can go Q is 2 pi, and then we're going to go 56 squared divided by 56 squared, minus 40 squared. Okay, so dissipated would be the energy lost between the first and second cycle, and stored would be the energy of the first cycle. Now we could tag along these, except we don't know mass. We could figure out omega, but it cancels out, so that's why we can just write it like that. Okay, so 2 pi times 56 squared divided by parentheses 56 squared minus 40 squared. This is 12.8. So that's about 13. I don't know how many sig figs we can really claim to have. I think we can claim to have a couple if we're reading a graph like this. Okay. Yeah.